Hi there, it's Miss Bracy with the Unit 5 Lesson 4 video, and for this video we're going to move on to our next method of solving quadratic equations, which is called complete the square. So there's two things we have to talk about in this video. We have to talk about how to complete the square and then how to solve a quadratic equation completing the square. First thing I want to talk about related to completing the square is what we call perfect square trinomials. So we know what dots is when we have a difference of two squares. A perfect square trinomial is when you have a trinomial and the first term and the last term are both perfect squares. So in this case, x squared is a perfect square and 4 is a perfect square. And so if you think about a regular trinomial where we would find two numbers that add to 4 and multiply to 4, those numbers are 2 and 2. So this trinomial that we call a perfect square trinomial factors to x plus 2 times x plus 2. Now that means that we are taking the binomial x plus 2 and multiplying it by itself, or in other words, we're taking the binomial x plus 2 and squaring it. So when we have a perfect square trinomial and we factor it like a trinomial, we end up with the same two binomials and can write that as the binomial squared. This is going to come in handy when we need to complete the square. But that's not what you're going to see. Here's the second example, just really quickly. The first term is a perfect square x squared. The second term is a perfect square 100. In this case, it says minus 20 in the middle. So two numbers that add to negative 20 and multiply to positive 100 are negative 10 and negative 10. And again, since the binomials match, we're going to have x minus 10 squared as a binomial. Okay, but as I said, that's not what you're going to see. This is what you're going to see right here. You're going to see x squared minus 8x, and you're going to have to fill in the third part of the trinomial. So the question kind of here is like, what can I put on this blank to make this a perfect square trinomial? So there's lots of perfect squares that can go here. So there's a very strategic way to find this. And the way we're going to do that is we're going to take this number right here, which is negative 8, and we're going to take half of it. So we're going to divide it by 2. So negative 8 divided by 2 is negative 4. Then, because this is called a perfect square trinomial and we're looking for a perfect square, we're going to square that number. So negative 4 times negative 4 is positive 16. So to make this a perfect square trinomial, we need a third term, and we're going to make that third term 16. Now if I do AM, if I look for two numbers that add to negative 8 and multiply to positive 16, the numbers are negative 4 and negative 4. So I get those same two binomials. All right, here's another example. X squared plus 10x. Again, the question here is, what can I make the constant or the third term so that this is a perfect square trinomial? So let's do the same thing. We're going to take half of 10, which is 5, and then we're going to do 5 squared, which is 25, and so to make this a perfect square trinomial, we have to add 25. What are the two numbers that add to 10 and multiply to 25? X plus 5 times x plus 5. Okay, one more example for good luck here. X squared minus 14x. So one more time, we are looking for the third term that would make this a perfect square trinomial. Take this number, negative 14, and divide it by 2. You get negative 7, and then negative 7 squared is 49. So if we put a plus 49 onto this trinomial, two numbers that add to negative 4 and multiply to positive 49 are negative 7 and negative 7. So x minus 7. Now, before we move on to how to use this to solve quadratics, I want you to look right here. What we did each time was we took half of the number, and then we took that number and squared it. Now, what I want you to notice is when we took half of the number, we got a number that we used again later. That negative 4 showed up in the binomial. When I took half of 10, I get 5, and 5 shows up in my binomials. And when I take half of negative 14, I get negative 7, and that shows up in these binomials. So that's going to be a little trick that you can use along the way. All right, so I guess the question then is, how do we use that to solve a question like this? So in order to solve a complete the square question, you are going to do this differently than what you're used to. You can get it equal to 0 to begin with, like we have been doing, but then you're going to have to move this constant back to the right-hand side, okay? So the constant should be on the right-hand side. All right, so keep that in mind. And so then what you're going to do is you're going to look over here and you're going to turn this into a perfect square trinomial. So you're going to rewrite x squared minus 8x, and then you're going to put a blank there. We're going to fill in that number that makes this a perfect square trinomial, equals 20, and then you're going to put another blank because if I put something on the left-hand side, I have to put it on the right-hand side. So we're going to figure out what that number is that makes this a perfect square trinomial, and then we're going to fill it in on both sides. So we're going to take this -8 right here. If you remember what I did before, I'm doing the same thing. So -8 divided by 2 is -4, and -4 squared, -4 times -4 is +16. When you complete the square, you will always get a positive number. So we're going to put a +16 on this line, and to balance out the equation, I need to put a +16 on the other side. Okay, so what I did here was what I was doing on the previous slide. I found the number that makes this a factorable trinomial, and so if I added on that side, I added on the other side. Okay, so what's next? We're going to do the same thing we did on the previous slide with this trinomial and find two numbers that add to -8 and multiply to +16. Remember, my hint to you was that we already found it over here. So this factors into x minus 4 times x minus 4 equals, and then we can add 20 and 16 to get 36. Okay, so I factored on the left-hand side and added on the right-hand side. Now we're going to do what you saw before, and because this is the two of the same binomial, we're going to condense it to x minus 4 squared equals 36. And so now what you have is a question that should hopefully look familiar because you can use the square root method to solve this question. Okay, now if you're still not sure how to use the square root method, you need to come see me and get some help on that because we're using the square root method to finish up this type of equation. Okay, so we're going to take the square root on both sides of this equation. Remember, the square root cancels out the exponent and this binomial stays as x minus 4 equals the square root of 36, as you know, is 6, but don't forget it's plus or minus 6. Okay, and so the next thing we can do, because these are whole numbers, we're going to go ahead and split this up into two separate equations. X minus 4 equals positive 6, and x minus 4 equals negative 6. And then we solve. So add 4, x equals 10. Over here we add 4, and x is negative 2. So the solutions or roots here are 10 and negative 2. So remember, these two words mean the same thing. We talked about the word roots briefly in class. Okay, solutions or roots mean the same thing, and that's what they are. Now, you're not always going to get whole numbers like I did here. You could end up with square roots, but for now, we're just going to stick with the whole numbers. All right, so we're getting a little short on time, but let me show you one more example so that you can get this written down, and then we'll do more of these in class. Okay, so first things first. You want to have your x squared and x on one side, your constant on the other side, and we have that. So now we're going to rewrite this with the blank on each side. Remember, we're going to add something to both sides, so we need that blank so that we know it's going on both sides. Now we're going to take our 12 and do our little trick. 12 divided by 2 is 6. 6 squared is 36. Okay, so we're going to add 36 to both sides. Okay, now we're going to take our trinomial here and factor it into two binomials. And remember, your clue over here was the 6. So x plus 6 times x plus 6 equals, and then negative 12 plus 36 is 24. That's like 36 minus 12. Okay, so now we're going to turn this into a binomial squared equals 24. And the next step is to, I'm going to switch colors here so you can see what the next step is, to take the square root on both sides. So that leaves us with the binomial x plus 6 equals plus or minus. And now before I write anything down, I'm going to simplify the square root of 24. So this is not a whole number, so we need to simplify the square root of 24, which means we have to find two square roots. One is a perfect square that goes into 24. So the perfect square that goes into 24 is 4, and it goes in 6 times. The square root of 4 is 2. So this is equivalent to 2 radical 6, which is what we're going to write down here. And I know this next part is the part that a lot of you are confused about how to solve this equation. You can split this into 2 separate equations, but I'm starting to think it might be easier if we do it this way. Let's subtract 6 on both sides. Notice how I'm squeezing the 6 kind of in front here because these cannot be combined together. So the 6's cancel out and we have x equals, you're going to bring down the number that you subtracted first, negative 6, then plus or minus 2 radical 6, and you are going to leave it like that. So that is your answer. If you split that up into 2 separate equations, then you'll get negative 6 plus 2 radical 6 and negative 6 minus 2 radical 6 as 2 separate answers, which really is the same thing as this right here. All right, so our time is up. That's going to be all for today. And just make sure if you have any questions that you bring them to class with you or type them in at the end of the video here. I'll see you soon.